Hey everybody, Mr. Stewart here once again, and welcome to part 3 of 3 videos on the binomial distribution. And this one just isn't with respect to the binomial distribution, but rather the focus of this video is on graphical representations, which can be applied to all probability distributions. So I thought we could use this particular example from the last video as a basis for establishing our graphs. So recall that the problem was about the recovery rate for a particular type of operation being 0.5 and 8 patients undergoing that operation. So when I first showed you how to use the wolphram-alpha website, so I took a screenshot here. Okay, so you can see that we are defining a particular range of values or number of successes between 0 and 8. So the number of cases 8 and the probability of success as 0.5. And the resulting graph looked rather nice, certainly with a success rate of 50% or 0.5. We ended up with a symmetric distribution. So the goal of this video is to start thinking or reasoning more graphically about the numbers that were given within any particular problem. Okay, so I felt it appropriate to ask a few questions of us. And for instance, number one being, what would the distribution look like if the success rate was higher or was lower? So we could take that particular example and sort of track and see what would happen. So throughout the course of the video, you're welcome just to watch the whole thing, but if you do want to have more of a hands-on approach to your own learning, I would definitely recommend going into the website, so to wolphram-alpha, which is exactly where I'm going right now, and to give it a try. So here we are. I'm just going to enter those particular values in that we had last time, at least for this particular example. And what we'll do is we'll re-establish the graph that was there beforehand. So here we go. So there is our wonderfully symmetric graph. Okay. What we'll do now is we'll kind of explore what happens when, as indicated in the problem, if we choose p-values that are higher or lower. And I would really encourage you to also anticipate, right? Make a prediction as to what you think it would look like. So if we were to set the p-value as being, let's start with higher. So let's maybe move from a 0.5. Let's take it up to, let's go to the extreme. Let's go 0.9. Let's take a 90% success rate. So what do you think would happen? Would we still have the same symmetry? Could it be possible that the lower number or maybe the higher number of successes becomes more or less prominent? Well, let's give it a try and see what happens. So here is our distribution. So when we increase the success rate from 50 to 90%, you can see that the number of patients that recover, so there's a greater probability that 8 patients will recover, more so than any other particular case. Okay, whereas before with the symmetric distribution, there was a probability for each particular case or a number of success. But here you can see that the distribution is a bit skewed. So when most of the values occur on the right-hand side as opposed to the left, we refer to it as a left skewed distribution. And the leftness applies to where we say the tail is of the distribution, not where the majority of the values are congregated. Okay, so in this case, we end up with a left skewed distribution when we increase the success rate. So similarly, Okay, or I guess conversely, in contrast, if we were to use a 0.1 value, so let's submit that and see, we should anticipate what we would call a right skew, okay? So with a lower success rate, it makes sense, right, intuitively, that the most probable case or number of successes would be 0, followed by 1, then 2, then 3, and very low probabilities that you would see all 8 patients recover with that success rate. Okay, so you can sort of see or appreciate how when you manipulate the value of P, you can really change the shape of the distribution. Okay, so anywhere along the lines of being skewed to something being a bit more symmetrical. And when you're presented with graphs, okay, or you have to interpret graphs with regards to distributions, you can then start to tell a story or to tell quite a bit about a particular context or situation. So there we have it. So, I mean, at this point in time, I would certainly make a note that when the n value was constant and the value of p was changed to be higher or lower, you could make some notes around skewness, left versus right, and relative to, you know, what the conditions are for symmetric distribution. So let's move forward and take a look at another question. And this one here is, what would it look like if you had a greater number of trials? So what if there were more patients or more opportunities to be successful, or at least we're tracking more successes? So let's go back into the calculator. What I'm going to do is I'm going to reset the p-value to 0.5. And we'll take the 8. Let's really boost that up a bit. Say, let's go for 100 patients. Okay, so looking for 100 successes. So we're anticipating a symmetric distribution and simply more values to track. So when you take a look at it now, actually the graph's actually quite beautiful, just in looking at that. Okay, so you can see that there are more values, right? Just looking at the vertical scale here, sorry, the horizontal scale. So we have a greater density of values, okay? And it's that density of values that is now creating, as opposed to a series of lines or rectangles, we really are getting quite a nice curve, or at least a curve would approximate the shape of this particular distribution. And in fact, the greater the density that we have, we're going to see later on as we study something called the normal distribution, that there is a possibility whereby we can use one distribution to represent or approximate values on the other. Okay, so here you have it. Now we could also experiment. I believe I asked a third prompt. And the third prompt was then to take under consideration numbers 1 and 2. So what would it look like if we increase the n value, or the number of trials, and also experiment with the p-value being, you know, greater or less than 0.5. So what we're going to do is we're going to maintain the value of n at 100, and then we'll look at changing the value of p. And as you saw before, what happens when we reduce that value? So I'm going to, I'm just going to change it ever so slightly. I think I'm going to go with the 0.4, and just to show some slight variation in the result. So you can see now the graph looks very much the same, but you can see that it has been shifted to the left. Okay, so the probability, that with the greatest probability here, has been shifted to the left. It's now just approaching, I guess 40 would be success rate here, okay, or 40% of 100. So let's go and try something else here. Okay, let's shift it even further. Let's try for 0.2 or 20%. Let's give that a try. So I think we can anticipate the graph shifting more to the left. Okay. This time you can see the average is floating around 20 patients. Okay, so at a 20% success rate for 100 patients, it's more likely to see 20 patients, right, recovering successfully, and so on and so forth. So that p-value, not the end value. The end value increases the density of the function, but the p-value is really what is shifting the graph from left to right. And just to show that in terms of 0.9, so let's go greater than 0.5, and we should see a left skewed graph, meaning that the density of the function, that is the majority of the larger probabilities, are going to be to the right of the scale, or of the horizontal scale. Okay, so hopefully the use of the wolphram-alpha tool has given you a sense of just how we can predict the distributions just by knowing the n and more so the p-value. Okay, and I think you're going to find that a graphical tool is not only a great way to represent, but could in itself be a helpful tool in terms of solving some problems. So that's all there is for this particular video. Okay, so you now have 3 videos on the series for binomial distributions. So if you have any questions, definitely do ask, or otherwise go back and maybe view particular parts of those videos to support you. You may have noticed in the last video that there were some assigned problems, so you may have already been working on some of those. They are posted in the course calendar, as well as here, okay, within the notes. So a series of questions for you in order to apply your current understanding of the binomial distribution.